Namaskar. I am Sandeep Chaudhari, working as Assistant Professor in Department of Electrical Engineering, All India Shri Shivaji Memorial Society's Institute of Information Technology, AISSMS IOIT, Pune. This presentation is about hunting phenomenon in case of synchronous motor. As shown in the slide, the stator rotating magnetic field and rotor are aligned properly. This is perfect magnetic locking. As we know, the motor works on magnetic locking principle. So the stator rotating magnetic field and rotor, their magnetic axis are coinciding. The stator N pole is facing rotor S pole on the upper side, and rotor N pole is facing stator S pole on the downside. So there is perfect magnetic locking, and due to this the motor runs, and it runs at synchronous speed. But when we load the motor, the rotor falls back a bit due to this loading effect, and the angle delta is created between stator magnetic field axis and rotor magnetic field axis. This angle is known as load angle because it is created due to loading on the motor. It's not that delta is initially 0 and it finally settled down to some value. In between the initial state and this final delta value, there are several oscillations of rotor that take place, and that is known as hunting. This is illustrated in the animation. We have loaded the synchronous motor, so rotor falls back a bit and it oscillates several times before it settles down to final delta position. So you might have observed there are oscillations of rotor. These oscillations are not desired. The final steady state position is shown by dotted horizontal line, that is the final position of rotor. So the rotor will oscillate around the final steady state position several times, to and fro, before it finally settles to steady state position delta. These oscillations are not desired because you have connected mechanical load on motor, and the oscillations will be passed on to the load and it may damage the load. So to prevent this happening, we use damper winding. As you can see in the rotor pole shoes, we have included round conductors, and these round conductors are shorted at both ends. So this construction resembles to squirrel cage induction motor, round conductors shorted at both ends with a ring. Now what happens whenever this hunting takes place, that means oscillations, these conductors which are embedded in the rotor pole shoe, they also oscillate along with the rotor, and when they oscillate they cut the stator rotating magnetic field and EMF is induced inside them. As we know, as per Lenz's law, the EMF produced during the process of electromagnetic induction opposes the cause of producing it. So in this winding known as damper winding, an EMF is induced which opposes the cause of producing it, and the cause is oscillations or hunting, and that hunting is eliminated. So as if this winding, damper winding, absorbs these oscillations or damps the oscillations, hence it is known as damper winding. You can observe the difference. Initially, without damper winding, we have several oscillations around the final steady state position indicated by that black line, but with damper winding, the red one, the response is improved. The rotor settles down to final steady state position in least possible time, and the oscillations are damped, they are reduced. So this is how the oscillations are eliminated. This is how the damping is achieved and hunting phenomenon is eliminated. Thank you. For more information, you can log on to www.aissmsiot.org.